Okay, in this presentation we are going to look at a specialized probability distribution known as the Laplace distribution. Okay, so I'll just read out the question here. A random variable x follows a Laplace distribution with location parameter mu equal to 5 and a scale parameter b equal to 2. Answer the following questions. So find the probability that a, x is less than 1, b, x is less than 6. Okay, you might think, is exercise A and B covering the same ground there? Is there a bit of a replication? Come back to that now shortly. X is between 6 and 10, and x is greater than 3.5, and also state the mean and the variance of x. Okay, so this is a worked example of the Laplace distribution, also known as the double exponential distribution. This distribution is often used to model data with heavier tails than the normal distribution. Okay, so it's sort of a specialist in that case. It's basically a heavy tail distribution, which is a lot of outlying values. Okay. So it has the following properties. The mean of the Laplace distribution is given by mu. So mu equal to mu. Okay. Mu is the location parameter, mu is the mean, so that is the center. It couldn't be more straightforward. The variance of the Laplace distribution is given as sigma squared equals 2b squared. Okay, so and that controls the spread of the distribution. Okay, so recall that mu is 5, and in the first question we're asked for x equals 1, about x equals 1, and in the second question we are asked about x equals 6. So this cumulative distribution function actually works on the case if the value is less than mu or if the value is greater than mu. So that is a difference between the two questions. So the first case, if x is less than or equal to mu, okay, so this is the case where 1 is less than or equal to 5. Okay, so we're going to use this first case here. The cumulative distribution function there is 1/2 of the exponential of x minus mu divided by b. Now looking at the second case, where x is greater than mu, in that case 6 is greater than 5, we would work on the basis of, we would use the cumulative distribution function of 1 minus 1/2 of the exponential of minus x minus mu divided by b. So we get x minus mu, divide that by b, and just get the negation of that, minus sign of that. Okay. So, exercise A, the probability of x less than or equal to 1. That is the cumulative distribution function of 1. Okay. And using our formula there, we just have to calculate this expression here. 1/2 of the exponential of x minus mu divided by b. That is 1 minus 5 divided by 2. That's 1/2. Sorry, it's minus 2. So 1/2 times the exponential minus 2. That is 0.0677. Okay. Straightforward enough. Exercise B is a contrast to that. In this case, x is greater than mu, so we're going to use the second case of the cumulative distribution function. F of 6 equals 1 minus 1/2 of the exponential of minus 6 minus 5 divided by 2. That is minus 1 divided by 2, so minus 1/2. So you have the exponential of exponential minus as half. So our cumulative distribution function is 1 minus 1/2 times the exponential of 1/2. That is 1 minus 0.3033. That is 0.6967. Okay, that's the answer to the second one. Now, find the probability that x is between 6 and 10. Okay, now just actually, I didn't go for anything too strenuous here, but what we will, because in both cases this is greater than mu, both 10 and 6 is greater than mu, so it should be a straightforward enough calculation. But essentially, if this was, let's say, 10 minus 3 or something like that, we would have to be paying attention to the two different versions of the cumulative distribution function that we'd be requiring here. But it's not so bad in this case. Okay, so f of 10 minus f of 6. Okay, so f of 10 is 1 minus the 1/2 of the exponential of minus 10 minus 5 divided by 2. And the second case is 1 minus 1/2 of the exponential of minus 6 minus 5 divided by 2. Now, I'm just going to rearrange that algebraically, okay? Just because we have 1 minus there and 1 minus on the other side, and we're subtracting one from the other, just to sort of clean things up, we express this as follows. That is 1/2 of the exponential of minus 6 minus 5 divided by 2, minus 1/2 of the exponential of minus 10 minus 5 divided by 2. Okay, so that works out to be 0.3033 minus 0.041, which is 0.2623, 26%, essentially, 26.23%. Okay, so nothing really major there. Just actually watch out when you're going from the third line to the fourth line, just to tidy up there, essentially. Those 1 minuses get taken out. Now, find the probability that x is greater than 3.5. Okay. So the probability x is greater than 3.5 is 1 minus the probability of x being less than 3.5. So that's 1 minus the cumulative distribution of 3.5, and that is 1 minus 1/2 of the exponential of minus 3.5 minus 5 divided by 2. That is essentially the exponential of minus 0.75. So you have 1 minus the exponential, 1/2 of the exponential of minus 0.75, and that works out to be 1 minus 0.2362, which is 0.7638. 76.38%. Now, finally, we were asked to calculate the mean and the variance of x in this example. So the mean is 5. Mu is 5. We sort of sorted that out. Very easy and straightforward matter early on. The variance is sigma squared, which is 2b squared, which is 2 times 2 squared, which is 2 times 4, which is 8. And that's us done. We'll leave it there.